Hello, everybody, and welcome back to another episode of Math. I hope you're all having a wonderful day today, but if not, it's about to get a little better because your boy Maths is here. All right, so today we are going to be looking more at the usefulness of prime factorization. So in the last couple of videos, we looked about how to split a number up into its prime factors, which are like these indivisible numbers that make up all of our numbers, all of our whole numbers. So today I'm going to show you a nice application of that and something that's really neat about prime factorization. So if you remember, we kind of started off these groups of videos by looking at the factors of a number. So if I took the number 24, for example, we would go through and list all the factors. So we'd get 1 and 24, 2 and 12, 3 and 8, 4 and 6, and you can go ahead and check that, right? And then a little later on, we looked at what is the prime factorization of 24. And so we can split that up into 2 and 12. Then we can split 12 up into 2 and 6. And we can split 6 up into 2 and 3. And as I noted in the last video, the many branches of the factor tree, we can actually do this factor tree in multiple ways. We could do it something like 24 goes into maybe like 6 times 4. We know that's true. And then we split 4 up into 2 and 2. Now we have those two primes. And we can split 6 up into 2 and 3. And now we have these two primes. But we get the same prime factorization that 24 equals 2 times 2 times 2 times 3, or 2 cubed times 3. All right, makes sense? So now what I'm going to do is I'm going to connect these two ideas. Both of these had to do with factors of 24, right? We see that the factors of 24 is this list here, 1, 2, 3, 4, 6, 8, 12, 24. And the prime factors of 24 are 2, 2, 2, and 3. And we see that, okay, the factors in here are 2 and 3, and that is present in our list here. So one might argue that maybe this list is a little more useful because we get more than just the prime factors, but we get every single prime factor. But what I'm going to show you now is that if we have the prime factorization, we can get every single number in this list. So let's go ahead and look at this prime factorization here. And what we're going to do is we're going to take every single combination of these numbers. All right, so let's look. So we have three twos and a 3. So one combination is a 2. The next combination would be 2 2s, right? And then the next combination would be taking 3 2s. And then we also have just 3 by itself as a valid combination. Then we can do 1 2 and 1 3. We could do 2 2s and a 3. Or we could do all 3 2s and a 3. Let's multiply these together and see what we get. So 2, we're just going to get 2. The pair 2 and 2, that gives us 2 times 2, which is 4. The pair of 3 2s, that's 2 times 2 times 2, that gives us 8. Then we have a 3 here in the next line. Then we have 2 and 3. That pair, 2 times 3, that gives us 6. Then we have 2, 2, 3. So we multiply all these together. We get 2 times 2, which is 4, times 3, which is 12. And then lastly, we have 2, 2, 2, and 3. When we multiply all these together, well, that is the prime factorization of 24, so we're going to get 24. What do you notice about these numbers that all of these combinations of prime factors just gave me? They are exactly the factors of 24, except 1, but we know 1 is always a factor anyway, so we're good to go there. But we see that 2 right there, 3 right there, 4 right there, 6 right there, 8 right there, 12 right there, 24 right there. Every single combination of prime factors of a number that is going to give us exactly the factors of our number. So I think this is like a really cool fact. So we don't actually have to go through kind of guessing and checking for factors anymore of a number. We can just simply find the prime factorization, look at every single combination of those numbers, and boom, we have its factors. So let's try this method to find the factors of 42. All right, so we'll start by factorizing 42. So we're going to look at it as factor tree. So I could split 42 up into 2 and 21. So we get a prime there. And I can split 21 up into 3 and 7. So we get these primes. All right, so that's a nice quick prime factorization. So we get 42 equals 2 times 3 times 7. So now what we do is we look at every combination of these. So 2 is a valid combination, 3 by itself is valid, 7 by itself is valid, right? These are just the prime factors of 42 pretty much. But now we can start combining them. So we could do a 2 and a 3. We could do a 2 and a 7. We could do a 3 and a 7. And then we could do a 2, 3, and a 7. So we then get the factors of 42 are, and we have to list 1 as well. 1, 2, 3, 7. And then we have 2 times 3, which is 6. 2 times 7, which is 14. 3 times 7, which is 21. And then 2 times 3 times 7, which is, well, that's just a prime factorization of 42, so that's 42 itself. And boom, we already have all the factors of 42. No guessing and checking, no divisibility rules required. We just immediately know what all the factors of 42 are because we knew what the prime factorization was. And I think this is just like a really, really cool kind of idea that we can start with this prime factorization and we get every single other factor. And the reason this kind of works is because, well, let's say we took 2 and 7, for example. We know that 42 equals 2 times 3 times 7, but if we took the 2 and a 7 and we multiply them, we get 14, and we know we have our 3 remaining. So we see clearly now that 14 is a factor of 42. Or let's say I did the 2 times 3. So I know that 42 is 2 times 3 times 7, but I could say, okay, 2 times 3, that's 6 times 7. So now we see clearly that 6, we're multiplying it by a whole number to give us 42, so 6 has to be a factor of 42. And so this is why we can use this prime factorization method, because we know that a number is equivalent to this product of prime numbers. But then since it's a product of prime numbers, we can kind of choose any combination of those to multiply, and we're going to get that product times whatever else you have is going to be a factor of 42 because that number now is in the product. And so let's try one more example really to just solidify this. So let's find all the factors of 100. All right, so it's a bit of a bigger number. So we'll start by looking at its prime factor tree. So I know 100 is 2 times 50. So I got 2 as a prime factor. I know 50 is 5 times 10. And I know 10 can be split up into 2 and 5. So we know our prime factorization is going to be 2 times 2 times 5, or 2 squared times 5 squared. All right, so now we just look at all the combinations of these numbers, and we're going to get every single factor of 100. So we're going to have 2 by itself, we're going to have 5 by itself, but then we can do 2 times 2, we could do 2 times 5, we could do 2 times 2 times 5, we could do 2 times 5 times 5, we could just do 5 times 5 as well by itself, and we could also do all 4 of them. 2, 5, 5. All right, so let's see what these get us. So we have 1 as well, right? Because 1 is always a factor of any whole number. We're going to have 2, we're going to have 5. 2 times 2 is 4, so that means 4 is a factor of 100. 2 times 5 is 10, right? 10 is a factor of 100. 10 times 10 is 100. 2 times 2 times 5, so that's 4 times 5, that's 20. 20 is a factor of 100. 2 times 5, that is going to be 25 times 2, or 50. 5 times 5 is 25. And then 2 times 2 times 5 times 5, that is just our prime factorization of 100, so we know that is just 100 itself. And boom, there's all our factors of 100. It's really easy. We don't have to check a bunch of numbers, and we're just done. So I'm not going to make a practice video on this because this is just a really small one-off topic, I think. But in order for you to practice, this is all you have to do. Pick a number, find its prime factorization, take every combination of those prime factors, take every combination of those prime factors to get all the factors of your number, and then you also have to include 1 like we've done. And then yeah, you're good. Like you've found all the factors of the number. And if you want to check your answers for any of this, you can just look up online. Okay, so let's see, pick the number 29 or something like that. Look up all the factors of 29. So there you go. I hope you found this video interesting. We're going to be getting into even more applications of prime factorization. It's such an incredibly useful topic with so many different areas that we can use it in. So we're going to be exploring those. But until then, have a good one, stay groovy, and I'll see you in the next video.